Hello everyone, this is Jim. For now, LX6V multi-axis motion function are developed into two parts, ECAM and EGEAR. And today in this video, I will introduce how to use 6V EGEAR function. Firstly, look at this EGEAR in function block. This function block is used to make the slave axis run follow the master axis according to the set speed ratio. So first we need to bind the master axis and the slave axis. And for the speed ratio, we can set it according to these two variables. Master value source 0 and 1 means the master position is got from the PLC, and 2 means the master position is got from the server. For continuous update, it's not support for now. So if you want to change the speed ratio, you need to give the best edge signal of this execute to modify. This is how these parameters work. So when we execute this function block, the slave will take the product of the master speed and the speed ratio as the target speed, and achieve the target speed under these three parameters: acceleration, deceleration, and drag. And during this process, if the master speed changes and cause the slave achieve the product of the master speed and the ratio speed, the slave will immediately into EGEAR mode and then follow the master to rotate. Now let's try it. Firstly, run a master and speed 5. And set the speed ratio. Here I set the ratio as 0.5. And now execute this function block. We could see the slave speed is speed up to 2.5. And here, this EGEAR is true status. Now if I change the speed of the master, for example to 8, then we can see the speed of slave is speeding up to 4. For this EGEAR out function block, this function block is used to make the slave out of the EGEAR mode, and then the slave will keep its current speed to run. Let's try it. And now if I change the master speed to 6, we will find the slave will keep speed 4, but not change to 3. Okay. Now look at this EGEAR in pros. This function block is a little different with this EGEAR in. With this function block, the sync speed is achieved and the sync point of the master and the slave. This is the slave sync position, and this is master sync position. The slave will begin to catch the speed ratio we set here only when the master achieves sync area. The sync area of master is dependent on these two parameters: master sync position and master start distance. For example, here if I set the master sync position as 50 and the master start distance as 20, Then when the position of master achieves 30, the slave will begin to speed up to catch the radial speed. And during the catching process, the motion parameters of slave will depend on these 4 parameters: max velocity, acceleration, deceleration, and drag. Once the slave speed achieves the product of master speed and the radial, the slave will enter in sync mode. And this is similar to this EGEAR mode. Here we can see this sync mode. This mode is used to determine the acceleration curve of the slave during the catching process. 0 means uniform acceleration curve, 1 means S-type acceleration curve, and 2 means T-type acceleration curve. And for others is same as this drawing. Okay, that's all about 6V EGEAR function block. Thanks for your watching.